Hi folks, welcome to my presentation. Today I'll be presenting blockchain as a storage medium for my BE 606 assignment number 1. So I want to take you back to the old days where we just had the internet, where you have to dial in to connect to the internet. So what was happening was you were dialing in from your cable and then you were connected to another machine. So that machine will connect you to another machine, to another machine, to another machine until you're connected to basically everyone that's on the internet. And that was a basically decentralized service where each person is connecting to each other person. There's no central server per se. And then we have the centralization that's happening because some companies like Arista was able to manufacture very cheap and efficient servers. So those servers were enabling people to be connected to those centralized servers. So most people, like let's say thousands, millions of people can connect to one service and that one server will connect to another server, which is, let's say, from the company, and that company will have their computers doing the work, and after they do the work, they'll send the information back to the server that's provided by your internet service provider, and you get the information instead. So what ended up happening with centralization is that people's communication are becoming more and more efficient. Like the servers are more efficient at switch labels, so the information and communication are able to become cheaper. And once you centralize all those data, you created a very large pool of data of user base, and that's when you're able to create a business using the economy of scale. So that's why we're seeing companies like Microsoft, Apple, Facebook, specifically those social media companies like Facebook, Google, and even nowadays TikTok, using the economy of scale, serving lots of people at the same time in order to create profit. But this is not without its weakness. So we remember last year there was earlier this year there was a large Amazon web service outage where the entire US East went offline. So most people have to revert their service to US West. And that caused a lots of issue and lots of vulnerability could be exploited. And we remember a year ago where the Facebook had a global outage where their entire domain went down, just disappeared. So the servers cannot make a meaningful connection to the entire Facebook server mesh. And when you have centralization, your information doesn't go from, let's say, person A to person B if you only want to send a message. So that involves lots of middlemen. So we can have vulnerability known as the man-in-the-middle attack, which is basically people intercepting your message or your query and adding malicious content into your message and perform their business objective. Let's say you're sending a request to your bank and they intercept your message and they change the target of the account you're sending to their account, and your money is lost. Or let's say you're sending a secret message to one of your worker, and that involves some sort of business secret, and that could be interjected. So we have lots of vulnerabilities. We have one point of failure due to the server outage, exploitation, and even the unnecessary cost on communication. Let's say I just want to talk to one person. I really don't need to have my message go all the way to Virginia and then go back to Ontario to be sent to the person whose house is, let's say, 10 meters away from mine. So um, with the recent technology advancement in blockchain, we really have a revitalization of decentralized technology. So in a decentralized world, there's no more one single point of weakness. Each person is connecting to each other, no more single point of weakness. You can't just attack a single server and bring down the entire network. And it's more efficient peer-to-peer because if you think about it, it's decentralization network is more efficient overall, but if you're only communicating to a few person, it's you don't need that much power, and it's actually lower cost because your message doesn't go all the way to Virginia, or if your company is in Europe and halfway around the world to finally come back halfway around the world to reach that person you want to communicate to. And there's no single man in the middle attack because your transaction is peer-to-peer. And with blockchain technology, you can't really attack it because using the man in the middle attack, because each message is immutable and stored on a distributed ledger, and that is immutable and stored across the entire mesh network. So if you attack it, it's just not going to work. And some of you may know that there's the 51% attack, which is when somebody owns like 51% of the entire network, and that enables the person to change the network and therefore performing an attack. Yeah, but that is a different, like blockchain eliminates the possibility of attack from like modifying stuff. But let's say somebody owns like 51% of the network, which is extremely rare. I mean, it's not seen at this time. And if somebody owns really 50% of the network, and that network is basically owned by that person, and that should never happen. Like, there are many mechanisms to prevent that from happening. And if that happens, then that network is worthy to be discarded entirely. So with decentralization, there's also the problem of slow and burning energy. Like, you have to you have to burn lots of energy to power the same number of transactions, and there's no more privacy because every transaction or every communication you make on the network is public to everyone. It's on the ledger, right? That's basically the fundamental principle of how blockchain works, which is everything's public. So all the networks are constantly checking to make sure the integrity of the blockchain. So there's no more privacy. But you may heard about that the blockchain is not anonymous, which is true. So your name is not on there, but your address is on there. So let's say if somebody can link your name to the address you own, then you basically have no privacy, which is exactly what's happening right now. Which when you register, say, an account in North America, you're being asked to provide your SIN or Social Security number, and that's how the government monitors the entire network nowadays. So really, we have lots of chains that's supporting its adoption. So if you remember back in the old days when blockchain just came out, it came out in the form of a Bitcoin. So Bitcoin was really designed as a value exchange system where you can view it as a currency in the beginning, where people exchange value, and they really made it based on their faith. So they believe that this Bitcoin is worth however much amount of money, so they will exchange the Bitcoin peer-to-peer. And because it is immutable, it acts like a money and prevents double spend. But really, it becomes more and more expensive, as I stated in the previous slide. So Bitcoin gradually became an asset rather than a value exchange medium. So that's when we have the second iteration, which is basically led by the Ethereum network, where people use blockchain to store assets and exchange small amount of information. Back in the Bitcoin, you can only store like a very short string, but in Ethereum network, you can store more data, a couple of bytes, sometimes a couple of kilobytes, but that's still very small. So we still have a long way to go to where we can store a bulk amount of information and use it as really a means of storage. So there are a couple of pioneers in the field. So we have CoinHost, which essentially is a hosting service, but they only use the name CoinHost in a way that you can use crypto payment for their hosting, but really they're a host. They're just riding the hype train, not providing any substantial value. And then we have like IFS. So IFS is based on decentralized storage, but it doesn't support bulk storage, and its underlying, like, it has the network that's hosted on the blockchain, but its underlying storage is based on traditional means. So it's a step forward from the CoinHost, which was basically I want to say it's a scam, but like it's just using the name and using the hype. So this is one step further. And then we have the Skynet blockchain. So the Skynet blockchain offers decentralized storage. It uses a concept called proof of storage. So if you participate in a network, you have to submit your proof of storage. Basically, you have 99.7% of uptime, and you're always online, basically, and you can preserve the renter's file intact, so you want to check if you can preserve that. So as a miner, you will be able, like you are powering up the entire network of information storage, and the renters will upload any files, like bulk files, into this server, and the renter uploaded file will be hosted and will achieve the target uptime. And if you as a miner who cannot meet the requirements, such as not keeping the target uptime, you'll be revoked of your access, and you will no longer be fitting in mining for this network. So this is really what I see, at least meeting the fundamental or like basic requirement of a blockchain as an information storage medium. So why is it important? Because in order to facilitate a network of information exchange, you cannot base that on a couple kilobytes. That's way too small. So in order to have a network of information exchange that's efficient, you have to be able to have storage like this, who can store a sizable amount of information in order to facilitate the information exchange. So where is this technology at its Porter cycle? So here I have a graph of the entire blockchain Porter cycle, but you can see that like cryptocurrency is very far into the right hand side of the curve, and lots of other concepts such as applications like up right on the top of the cycle. So actually kind of draw my own cycle. So on the right you can see my cycle. So the graph that's like stretched is the current the information is exchange cycle. So you can see that it's kind of right in the trough right now. So we had the hype that's the cryptocurrency that happened like way past like 6 or 7 years ago. Nowadays everybody owns that. So that's the curve in the middle you see. So it's the line. So we can see that the trend of cryptocurrency kind of pushes forward the trend of adapting blockchain as a medium application network, and then it's also pushing this blockchain as an information exchange. So these are the trends supporting the adoption of blockchain as an information storage medium. So as you know, in every industry there are many forces that's affecting the adaptation and competitiveness of a technology. So I kind of research its competition according to Porter's 5 forces. So we have the threat of new entry. So lots of companies, even for example Meta, which is formerly Facebook, that's researching how to store information securely on a blockchain, and I think they have recently manufactured their own attempt at blockchain. They had one attempt at cryptocurrency, which is Lira, and they had one attempt at information exchange, that's Ripple. And we have lots of fintechs seek to create entry into to make some quick profit. We have the bargaining power of suppliers. So the technology-wise is open source. It's based on SHA-256 technology. So there's no bargaining power of supplier on the tech side. But on the miner side, so the cost is heavily associated with the cost of the mining equipment. So mostly are manufactured by GPU manufacturers such as NVIDIA, AMD, and sometimes Intel. So the suppliers really determines the base of cost, and if the supplier increase costs, then the cost of adapting will be higher, and the pace will be slowed. And so we have the bargaining power of consumers. So we don't have a sizable consumer of this technology yet because it's not widely adapted. And the entire existing information storage and exchange network, that's our substitute. So this is the network that this technology is seeking to disrupt. And there's no predominant industry solutions in this field yet, but we see, well, we see that lots of existing, I would say, second generation tech in blockchain as potential industry competitors, such as Ethereum, which can store lots of information, and facilitate exchange, which is the basic network that's facilitating such business objectives so far. And key technologies required. We have basically the entire internet infrastructure provided by the ISP, internet service provider provided by lots of service switching technologies, and also the SHA-256 technology is the key for encrypting in the world cryptographics. That basically runs a linear time algorithm that converts any length of data into a consistent 256 bits, 4 bytes hash. So the hash is irreversible, so it cannot be used to crack its original content, but it's unique, so any information can be identified by a SHA. So that's how the blocks are being hashed and distinguished apart. So really, these are the key technologies and forces that support its adaptation. And I really see that this technology is right now at its trough, after being hyped up for like 2 years in the past too. And but I will say it's still kind of riding downhill in its hype cycle. So we hope to see more companies really like stick to the ground and like work on this technology and make it more feasible and adaptable to mass consumption. And thank you for listening to my presentation.